In this video, I will show you how to solve some real-world problems involving conic sections. Roads are designed with parabolic surfaces, that's a parabola, to allow rain to drain off. A particular road that is 32 feet wide is 0.4 feet higher in the center than it is on the sides. Find the equation of a parabola that models the road surface by assuming that the vertex of the parabola is at the origin. First thing you need to do is draw a picture. Now, this is the curvature of the road. Of course, I've exaggerated greatly the curvature of the road. Roads are not this round, but I just want you to be able to see the curve happening. Now, the road is supposed to be 32 feet wide. So that means 16 feet to the left of the center and 16 feet to the right of the center. They also said that the height at the middle is 0.4 feet higher than it is on the sides. So another way of looking at it is that, well, basically we're saying that this distance right here between the top of the road and the height on the edges, that's a distance of 0.4 feet. All right, this hill is sort of 0.4 feet tall, if you will. So let's go ahead and label a few key points that we know on this parabola. Of course, we know that the vertex is 0, 0, because we were told to put the vertex at the origin. But we also know the coordinates of these 2 points on the edges of the road. Because this point is 16 feet to the left of the center, so this is negative 16, comma, and it's 0.4 down, so that's negative 0.4. So those are the coordinates of this point. Similarly, the coordinates of this point are positive 16, comma, negative 0.4. So we can use however many of those we need to find the equation of the parabola. Now, this is a downward facing parabola. It's vertical, so we know that the model we're going to use is the one where the x is squared. So I started to write x minus h. I started to write x minus h squared. Come on, pen, let's go. Alright, I might have to not change colors anymore. X minus h squared is equal to 4p times y minus k not squared. If you have a vertical parabola, you use the version of the formula where the x is squared. But since the vertex is 0, 0, that means h and k are both 0. So the equation becomes x squared is equal to 4p y. So we need to figure out what p is. So how are we going to do that? So I'm going to come over here. Maybe I'm going to recopy this for a second. So I've got this equation, x squared is equal to 4py. I need to find p. So what I need is an x and a y that I can plug in. Well, guess what? We have an x and a y right here that we could use. So I'm going to substitute those. So that'll be 16 squared is equal to 4p times negative 0.4. Okay, 16 squared. Okay, I'm jumping on my calculator real quick. So 16 squared is 256. 4 times 0.4 is 1.6. So I will have negative 1.6 p. Now I need to divide both sides by negative 1.6. So let's see, 256 divided by negative 1.6. That is negative 160. Okay, so P is equal to negative 160. Okay, so great. So now I can take this P value and put it back into the equation that I was trying to make. So I will have x squared is equal to 4 times negative 160 y. So that'll be x squared is equal to, let's see, times 4. So that is negative 640 y. So this is it. This is the equation of the parabola of the road. Let's do another real-world problem. An arch for a tunnel is in the shape of a semi-ellipse. All right, that's half of an ellipse. So if an ellipse is like this type of deal, boom, a semi-ellipse would just be like the top half, for example. Anyways, the distance between the vertices is 120 feet, and the height to the top of the arch is 50 feet. Find the height of the arch 10 feet from the center, round to the nearest foot. Let's draw a picture. Okay, so here is the arch of the tunnel, a semi-ellipse. The height to the top of the arch is 50 feet. Okay, so this distance right here is 50 feet. That means I've put 0, 0 at the center of the ellipse. All right, just to make things easier. That means this point at the top of the ellipse is going to be the point 0, 50 because it's 50 feet high. What other information do they give us? Okay, the distance between the vertices is 120 feet. Okay, so look, this is a vertex and this is a vertex. So that is 120 feet. That means it's going to be 60 feet on each side. So this is 60 feet over here, 60 feet over here, for a total of 120 feet. That means the coordinates of this point right here will be 60, 0. And this point over here would be negative 60, 0, even though we probably won't need that. Okay, so we're supposed to find the height of the arch 10 feet from the center. But to do that, we need an equation for the ellipse in the first place. Okay, so this is a horizontal ellipse. So I'm going to use the model that goes x minus h squared over a squared plus y minus k squared over b squared equals 1. This is the general shape of the equation for an ellipse. But actually, h comma k, those are the coordinates of the center. So since the center is here at 0, 0, I'm not really going to need the h and the k. So I'm just going to have x squared and y squared. So let me simplify. So it's just going to be x squared over a squared and y squared over b squared. So the a value is the distance from the center to a vertex. So I know that a is 60. Therefore, a squared is going to be 3,600. Similarly, the b value is the distance from the center to a covertex. They gave us that as well. B is 50. Okay, which means that b squared is going to be 2,500. So we can substitute these values in for a squared and b squared. Notice if you weren't sure about which one would be a squared, which one would be b squared, what really matters is the fact that this 60 is horizontal. It's in the x direction. So of course the 3,600 goes in the x denominator. The 50 feet is vertical. That's the y direction. So the 2,500 will be in the denominator of the y term. Okay, so look, that is the equation for this ellipse. So if I want to find the height of the arch 10 feet from the center, okay, I'm talking about, okay, you know what, let me just erase a little of this work that I've done. Okay, so here we are 60 feet from the center. We're at the ground, 60 feet from the center. 10 feet from the center might be like, for example, right here. Okay, if we're 10 feet from the center, then this is 10 right here. And what we're looking for is the y value. So the x value is 10, and we want to know what is the y value that goes with that. So all we have to do is let x equal 10 and see what happens. Okay, so 10 feet from the center, x is equal to 10. I'm going to plug that in and get the height y. So that's going to be 10 squared over 3,600 plus y squared over 2,500 is equal to 1. So this is 100 over 3,600 plus y squared over 2,500 is equal to 1. Well, this reduces to 1 over 36. So that's something. I've got y squared over 2,500 is equal to 1. I'm going to go ahead and subtract 1 over 36 from both sides. Okay, so that's going to give me y squared over 2,500 is equal to 1 minus 1 over 36. 1 is an interesting number because you can rewrite it as anything you want. 2 over 2, 3 over 3, 5 over 5. I'm going to replace 1 with 36 over 36 because that way I will have like denominators. So I think I'm going to need a little bit more space now. So if I do that, I will have y squared over 2,500 is equal to, now this is 36 minus 1, so that's going to be 35 over 36. Okay, I'm trying to get y by itself. So now would be a good time to multiply both sides by 2,500. Because that way these will cancel each other out. So that's going to give me y squared equals, and I'm just going to calculate all this out. So what had happened was I multiplied these, I got 87,500 over 36. I'm going to have to take the square root to get y, and that turned out to be 49.3 feet. So that's the answer. All right, that is the height of the tunnel 10 feet away from the center. That does make sense because the maximum height is 50, and we're just a little ways away from the center. So it would make sense that it should be just a little bit less than 50. So 49.3 is a reasonable answer. Number 29, a whispering room is one with an elliptically arched ceiling. If someone stands at one focus of the ellipse and whispers something to his friend, the dispersed sound waves are reflected by the ceiling and concentrated at the other focus, allowing people across the room to clearly hear what he said. Suppose such a gallery has a ceiling reaching 20 feet above the 5-foot high vertical walls at its tallest point. So the cross section is half an ellipse topping 2 vertical lines at either end. And suppose the foci of the ellipse are 30 feet apart. What is the height of the ceiling above each whispering point? Let's draw a picture. So the wording here is a little awkward. Let me see if I can make you understand what they're saying. They have these 5-foot vertical walls on either side. So this is 5 feet and this is 5 feet. Okay, can't spell feet. Now, the top of the ceiling goes 20 feet above this. So they're saying that this distance right here is going to be 20 feet. So this is important. I have allowed the center of the ellipse to be at 0, 0. That's why I have the walls, the 5-foot walls, stretching underneath the line, because I'm going out of my way to make sure the center of the ellipse is at 0, 0, just to make the calculations easier. So I am going to need an equation of this ellipse to be able to do anything. So remember, if I have a horizontal ellipse like this, the equation is going to go, well, normally it would be x minus h squared over a squared plus y minus k squared over b squared equals 1. But the center is 0, 0. So I don't need the h and the k. So I can simplify this a lot by putting just x squared and y squared. All right. Now, the a value is the distance from the center to a vertex. We don't have that. So I'll have to deal with the a value later. But the b value, we do know. B is 20, because the b value is the distance from the center to a covertex, and that's what this point is on the ceiling. So b is 20. That means that b squared is going to be 400. So I can put that into my equation. All right, that moves me one step closer to having a complete equation, because this is going to be 400. Now, they gave us one more piece of information that I have not included in the picture yet. They said that the foci of the ellipse are 30 feet apart. Okay, so the foci of the ellipse are on the same line with the center, and so these are 30 feet apart. That means that this distance right here is 15, and this distance right here is 15, because they're a total of 30 feet apart. However, the distance from the center to a focus is the c value. So now we know that the c value is 15, which means that c squared is 225. That's important because now we have c squared and b squared. We should be able to find a squared, no problem, because we know that for an ellipse, c squared is equal to a squared minus b squared. So c squared is 225. We're trying to find a squared. B squared is 400. So all we need to do is add 400 to both sides. So that tells us that a squared is equal to 625. So boom, we'll just drop that into this denominator, and our equation will be complete. 625. By the way, if you ever were unsure about a squared versus b squared, just remember, this 20 was vertical. That's the y direction. So the 400 will definitely go in the denominator of the y term. If it goes in the y direction, it goes in the y term. Okay? And that left the 625 to definitely go with the x term. So anyway, now we have the standard form equation for this ellipse. So we have one last thing we have to do. We have to use this equation to find the height of the ceiling at a certain point. The question says, what is the height of the ceiling above each whispering point? Well, the whispering point is the focus. So they're asking us, what is the height of the ceiling right here? Okay, all right, they're asking us, what is this height? Now, this is a y value, all right, because we're talking about height. Whereas this 15, the focus, we know the x value. Basically, the x value is going to be 15, because we're 15 to the right of the origin, and we're being asked what the y value is for this x value. So we just need to substitute 15 for x and then see what the y value is, and that'll be the height above the focus. And that should be the same, because of symmetry, it'll be the same on the other side as well. Alright, this will be the same y value. Okay, so substituting 15 for x, commence. Let's see. What color should I use? I think I'll just use gray. So if I substitute 15 for x, I will have 15 squared over 625, okay, plus y squared over 400 is equal to 1. So this is 225 over 625 plus y squared over 400 is equal to 1. This reduces down to 9/25, by the way. Okay, plus y squared over 400 equals 1. Let's go ahead and subtract 9/25 from both sides. So that's going to leave us with y squared over 400 is equal to 1 minus 9/25. Well, I love the number 1 because this can be equivalent to 2 over 2 or 3 over 3 or 4 over 4, etc. So I'm going to replace the number 1 with 25 over 25 so that I will have like denominators. Okay, so 25 minus 9 is 16. Alright, I think I'm going to need more space at this point. Okay, so I've got y squared over 400 is equal to 25 minus 9 is 16, so that's going to be 16 over 25. Time to multiply both sides by 400. Alright, so those will cancel out. So that's going to leave me with y squared is equal to multiply those, I get 6,400 over 25. So that's y squared is equal to 256. So take the square root of both sides. I should know what this is, but 16. So y is equal to 16. So for a minute there, I was thinking that we were done because we found the y value, we found the height. and this is 16 feet. Yay! But that is not quite the final answer, because I was forgetting about the extra 5 feet vertical walls on either side. So the actual ground is this. I sort of wrote it as a dotted line, but like this is the floor right here. This is the actual floor, like where people walk around. So the height of the ceiling is going to include the 5 foot height of the vertical part of the wall, plus the y value above the center of the ellipse. Okay, above my x-axis here. So basically 16 plus 5, so 21 feet in total. I like to finish off my word problems with a nice summary statement. So the ceiling is 21 feet high at the whispering points. And again, that's 16 feet above the origin plus extra 5 feet for the walls. Alright guys, that's going to do it for this video. Go ahead and click here in the red apple to watch the next video. Click in the green apple to subscribe, or click the yellow apple for the full playlist.